Hey, thanks, Adam. Nice to see you again, and welcome everyone. Good morning, good afternoon, good evening, wherever you are. As Adam introduced me briefly, I am Noorddin. I'm part of Strategy and Architecture Group, and currently working in Intelligent Operations (BP), where we work with new technologies. And digital twin is one of those technologies that I'm very excited about, and very excited to moderate this panel, where we're going to talk about how new technology, specifically digital technology, digital twin, is going to support our ESG initiatives and help us meet our net zero commitments. So let me introduce, before I introduce our panel, esteemed panel, which will participate in a great discussion and unpack this topic a little bit more. Just introduce the topic. So digital twin, as everybody knows, digital twin is a digital replica of an asset that integrates the digital data from digital and physical world, and how it play a key role in climate change. The AI techniques could use a digital version of the Earth to help fight the climate change. And applying these techniques to test climate savings initiative across digital twin of the Earth could help us tackle the climate change. Digital twin will empower ESG initiatives to model what new sustainable future will look like more precisely, and then execute on the vision to its completion. Digital twin will enhance predictivity, reduce downtime, performance tracking, and continuous improvement in energy efficiency. It provides visibility across the asset landscape, which opens up, digitization and improvements, and it helps us fight the climate change. It also enables the automation, which is really going to reduce improve efficiencies and reduce the emissions. So with that, I would like to introduce, and I think I would allow them to introduce themselves. So I will start introducing our panelists. So we'll start with, you want to introduce yourself?
Sorry.
I can't hear you, Otavio. Okay. We can't still hear you.
I'm sorry.
You're
Hello?
muted, Otavio.
Yeah,
No, I'm not.
now we can hear you. Go
No,
ahead.
I'm
So,
not. You can hear me? Okay. Sorry for
yeah,
that.
yeah.
Technical problem. Sorry. uh, so my name is Otavio. Thank you, Noorddin. So I'm founder and CEO of Vidya. We are working with digitalization, digital twins, and also digital transformation of operation and maintenance phase of industrial assets. We are creating pretty advanced applications of digital twin for some parts of the operation, industrial assets like FPSOs and other types of facilities in energy sector, mining, and other industrial environments. My background is engineering, mechanical engineering and metallurgical engineering, with some background in asset integrity management. We are working for the past like 10 years with optimization of operation and maintenance using technology. So thank you again for the opportunity here.
Thanks, Otavio. Now we move to Alberto. Do you want to introduce yourself?
Hello everyone, Alberto Iniesta. I started my career working for Honeywell UOP 15 years ago. At that time, I was a commissioning and startup engineer. Then I joined Repsol, which is an oil and gas operator. I think some colleagues from Repsol were participating in this forum as well. First, I was working as a process engineer for a number of years, and then I started to work in digital twin technologies. I was the owner for all digital twin implementations across the E&P business for Repsol. And just a few months ago, I joined Worley, where I'm working as a senior advisor for digital twin and APM solutions.
Thanks, Alberto. Ashraf?
Hi, Ashraf Wardeh. Good morning, everyone, or good afternoon, depending where you are. I'm the IT Business Engagement Director for Oxy. Basically, we work with the business units to look for innovation and improvement opportunities. Most recently, I'm looking after the Gulf of Mexico and our low carbon venture, where we're actually building a direct air capture facility. And we're looking to use all these technologies to help us improve operations, reduce downtime, and reduce our emissions as well. So looking forward to the discussion today.
Great. Thanks, Ashraf. Miriam?
Good morning, good afternoon, good evening. So my name is Miriam Archer. I've worked for Schlumberger for all of my career for almost 20 years now. I've worked in various different aspects, from research to working offshore in drilling, engineering. And for the last 9 years, I've worked in our digital and integration division, creating digital twins. So, and then for the last 3 years, I've been working on the sustainability side, and have been balancing my time between creating digital twins for oil and gas applications, and then CCS applications, and also hydrogen and wind applications as well. So very excited to be on this panel and share a bit of the digital twin with regards to ESG concerns.
Thanks, Miriam. Amit?
Thanks, Noorddin. I'm Amit Jain. I'm a functional advisor for digital twin at Chevron. I have worked in both upstream and downstream facilities in operations, process engineering, process automation. I would say like around more than 10 years ago, I had built online and offline process physics-based models for facilities and pipeline, which are nowadays called as digital twin. But since then, a lot of things have changed. So I look forward to having a robust discussion with the panels on how things have changed and what additional innovation is needed for us on a journey towards lower carbon. So I look forward to this discussion.
Thanks, Amit, and thanks everyone, for joining this panel, and looking forward to exciting conversation. All these panelists have worked in digital twin for many, many years and brings a lot of experience and expertise that I'm sure that our panelists will provide, their views on digital twin and how the digital twin has improved their operations, efficiencies, and added value to their organization. So with that, I want to start my first question. So for our audience, just explain, and I know I briefly talked about digital twin is a digital replica of a physical object, and once you digitize something, it opens up opportunities across the board to improve and improve your efficiencies and optimize your processes, improve your design and stuff. So let's start by defining what's your definition of digital twin, and then just talk briefly, how you use digital twin in your organization to drive value. So I'll start with Amit. If you want to talk a little bit about, your definition, how do you think what digital twin is?
There are multiple definitions of digital twin, and when you look at it, like there is a data digital twin where you're bringing in data of your facility design into the digital twin framework. Then there is operational digital twin where you're trying to bring in operational data, real-time data to drive operational decisions. Then there's process digital twin, which is where you're trying to predict what is going to happen. So there are multiple definitions, but more than definition, I feel we should be looking at what is the impact and how it's going to be used. So in the end, keeping the definition apart, it should be what workflows are we looking at, how the workflows are going to change, and how does the digital twin help us improve our workflows and be more streamlined and help our decision quality.
Thanks, Amit.
And
Okay,
if
please
I
go
can,
ahead.
I can complement what Amit said, maybe we will need to establish a data workflow between the replica and the physical asset, which is a topic that we can discuss deeper. So I believe for a whole panel, but the data issue. But also for me, the main detail on developing a digital twin is to exactly define the application, the pain point we want to solve, and how we're going to interact with the data in the environment that application will have. And I mean the environment, I mean not only the physical environment, which is important, of course, to create this replica, but also the IT environment you have, the operation data you have, how you can recall engineering data to develop to help this application using digital twin. So the important thing is how we're going to solve something and generate a value proposition using the digital twin.
And Otavio, you're absolutely right on that one. So that is why I always say that we have to start with what workflow when we are trying to impact, what decisions we are trying to impact. So once you have that line of sight, then building everything around it is much easier, and also demonstrate the value of that is much easier.
Yeah, correct.
I think around this discussion is, and I think one of the values that the digital twin brings is that it helps to break silos between the different technical disciplines, no? And it doesn't matter if you are talking about the design phase or operational phase. I mean, it helps the teams to work in a more integrated fashion, so you get a better integrated view of assets and projects. So during the project phase, you will have the people from civil engineering, electrical, instrumentation and control process. They will all have the same considerations, the same. They will all be working on the same basis without any discrepancies.
I lost Alberto.
We lost Alberto.
Yeah.
Anyone else? I think you made a very good point, about. Yeah, go ahead, Miriam.
Yeah, I was going to jump
Miriam,
in and say,
go?
I think these guys are absolutely right, and I really like the.
Okay,
we lost you.
Sorry, go ahead.
Can you hear me?
We lost you, Alberto, for a second. Yeah, just go ahead. Continue your.
Yes, I was saying that something that I think is very, very important is that the digital twin embeds in business processes. So you would be able to just get rid of all the long, let's say, documents based on paper, and you can generate workflows and automation, and be able to complete end-to-end processes by means of the digital twin solution.
Thanks, Alberto. Miriam, go ahead. Continue, please.
Yeah, so I really like the Advanced Manufacturing Research Council's definition of a digital twin, which is that it is a live digital coupling of the state of a physical asset or process to a virtual representation with a functional output. And I think that functional output is the key bit where it brings the value, right? Not only for you have to specify the workflow in order to really define what your functional output needs to be. But then once you have defined that workflow, then as we were saying previously, it then leads the value between the integration of all of the different domains, so that integrated decision can be made most effectively, thus reducing downtime within the system, or reducing energy wastage within the system, making the whole process more efficient, and have a less of an impact on the environment as well.
Thanks. Before I go to, I just want to make what Alberto mentioned. Very good point. That the silos, so we have in an organization, we have silos happening in patches, and nobody has visibility of end to end, what's going on. So that digital twin brings a lot of value in filling that gap. So now you have a visibility to end-to-end process. It means that you can see exactly what's going on. So that will allow you to improve your process. The other thing, what Miriam, you brought up a good point about digitization of operations. So when you digitize anything, it opens up a lot of opportunities. For example, it reduces the cost to make changes to the digital versus a physical, and then it allows you to optimize the is our design with lower cost. So those are the key benefit we get from digitizing an asset. Ashraf, do you want to add anything? You're mute.
Can you hear me okay now?
Yes,
Yeah.
go ahead. Go ahead, please.
I think everyone has a really great point. And building on the silos, I think one of the biggest thing of when we talk about digital twin is you're bringing data from different places and you're connecting it together. You're creating relationships between those silos, and that's what really adds value at the end of the day, is the ability to say that using this connected data now, I can start looking for insights and way to simulate and streamline processes. So I agree digitization is important, because without digital data, you cannot create the digital twin, which replicates your physical world, and also the ability to connect this data together and make it more natural, where it represents your physical world, basically. I think that's where we see a lot of value.
It's great. Thanks, Ashraf. And I'm going back to you again, Ashraf. So now let's talk about the downtime. So digital twin. What role digital twin plays in reducing that downtime? I understand, there is the predictive maintenance. If you look at it, then you probably know ahead of time if something is going down, so you can avoid it. But I would like to hear from you, Ashraf, and others, what your experience is for reducing downtime with the digital twin technology.
So digital twin is an implication of a problem like we talked about. What is the problem you're trying to solve? So if we talk about downtime, using digital twin concept, you're going to be able to not just predict the downtime of an equipment, but also connect that to other processes within your system. So your prediction becomes more accurate, and also will give you full visibility to your process and the system of systems of your process. So building a very predictive analytics around one equipment is very siloed again. But when you connect that to the overall process in your digital twin, you can now start to see failures before they happen, and allow you to identify the root causes behind them. So digital twin simulation and having data available to do that kind of prediction definitely has helped us identify and increase our uptime with our facilities. So it creates that visibility and allow you to identify and have your engineers and data analytics people look at the data holistically, not focus on one real-time data set, but connect all that together and create predictivity with that.
Thanks, Ashraf. So Miriam, do you want to, provide your view, and then also connect this, how, this downtime reduction is directly supporting the ESG initiatives or reducing the carbon footprint?
Sure. So I'm coming at this more from the point of view of the design of the system in the first place, as that's where our digital twins tend to be used rather than real-time operations. And where it reduces downtime from our point of view and from our experience is that obviously you have to size the system correctly to minimize downtime. And that's where our digital twins come into play, because they model the system as part of the design process, make sure all the physical items, valves and separators and so on, are sized correctly for the predicted throughput. Now, obviously, there is a lot of uncertainty in the oil and gas industry, particularly related to the subsurface. And so with our digital twins, you can map out that uncertainty space to come up with a set of scenarios such that you can predict with the highest confidence. You can never predict with 100% confidence, but then if you have a variety of scenarios, you can predict your highest confidence scenarios, and then you can make sure that your system is sized correctly when it goes into the operational phase. And then throughout the operational phase, you then need to check back with your model, update it as appropriate, so that then you can make changes and adjustments as operations progress. Now, where that has the effect on the environment, obviously, through minimizing downtime, that has an immediate effect on the environment, because then there's less wasted energy, and we all know that the cleanest form of energy is the energy that you haven't used, right? So minimizing downtime minimizes energy usage, and therefore has a less detrimental effect on the environment. Now, one of the trade-offs is that creating a digital twin and running all of those models, particularly in the uncertainty space that I talked about previously, that has an effect on the environment as well, through the use of electricity in the computing of that digital twin. And so we have tended to shift our digital twin computation to the cloud to minimize that need to run such compute intensive data centers on premise. And in the cloud, we can take advantage of the elasticity so that we only use the energy that's needed, again, because the cleanest energy is the energy you don't use.
It's a good point, Miriam. So, Amit, I have a question for you. If you want to, I know that you have experience in physics model and analytic model. So, if I say, it's very important for downtime prediction. There is a data that's coming in, historical data that tells you, when the machine's going to fail or operation is going to be shut down. So that's one point of data. And then we also have a physics model, which is also going to sit on top of it. So if you wanted to, help our audience provide your view on, is this physics-based model is more robust versus the data model or analytic model, or you would suggest that combination of both would give us the best predictive modeling?
So this question is very close to my heart because there's always a struggle. Okay, do I go with the physics-based approach or do I go with a database approach? Where in some cases, when the physics is very well understood and we have good robust models that exist, then physics-based model would always be my first choice, because when I have physics models, I can go beyond the conditions in which the facility is operating and try to optimize from that perspective. The data model, when I do not have a very good understanding of what's going on, in that case, a data model does help. But one of the limitations of data model is that when I'm trying to optimize and I'm trying to make decisions, I have to make sure that I'm not extrapolating way further from where the data exists. So to answer your question, physics-based model would always be my first preference, and if that doesn't do the job, that's when I will lean on a database model. And again, even when I'm using my database model, I have to be very cognizant about the fact that I'm not extrapolating way beyond where the data exists already.
It's a good point, Amit. And what my view is, I want to give you my view. When we deploy, we're just working on digital twin, and we want to deploy a digital twin solution for an equipment. And we don't have any historical data, to start with, because if you wanted to use AI, more data that you have, more historical data that you have, just like you said, you can predict, you can use the algorithm to predict when it's going to fail or what the future looks like. But physics-based model, the physics existed for a long time for specific, equipment or the processes. Then it actually gives you a head start, and then you continue to collect the data, and then when you have historical data, so it actually enforces your decisions. So you have one model, and then on top of it, you put another model, so that will give you a better accuracy on your prediction. Anyone else has any comment? this is just my view. That's what the way I look at it. But I agree with you, Amit. Yeah, physics is more robust, and definitely it's going to give you a heads up.
And one more thing I do want to add to what you just alluded to is basically when you are building a physics model, yes, there is a lot of history and knowledge behind building this physics model.
Mm-hmm.
When we are
Yeah.
going with a database or analytical model, it depends on what you're putting in. So if you have not accounted for everything that is going to impact the process, then it is like garbage in, garbage out kind of situation. So
Exactly.
if you are going to use an analytical model, make sure you understand you're accounting for everything that is important.
Very good point, Amit. And I think in any data analytics, just like you mentioned very rightly, it's garbage in, garbage out. The data quality is important, and if you feed the incorrect data, then your model is not going to be accurate, and then you will make the wrong decision. Anyone
I
else
think,
want to comment on this?
yeah,
Go
I
ahead,
think there
Miriam.
is a scenario where you can have a hybrid model as well, right? So you use the physics as much as you have, and then you supplement additionally with the data that you have as well. And that's often what we do in the uncertainty cases that I was alluding to earlier.
Yeah, exactly. And in some cases, there is no data can replace the physics model. And just, for example, the gravity, if you wanted to replace gravity with data, it's going to be a challenging task. It will possible, but it will be a challenging task to do that. Otavio, Alberto, or Ashraf, you have any comment on this topic?
Yeah, I would like to bring my view on this. I think something that is important when you're talking about physical models is to first to audit and have model management capabilities against those models. So you make sure that at enterprise level, people know which models are the ones that should be used. Then as well, when you're using physical models, you should calibrate those models. So you will require to perform QA/QC over those models, and you will require a robust data layer with cleansing and real-time data processing capabilities. So you will see the performance of your physical model against real-time data. And then once you have these two layers is when you start performing surveillance, optimization, forecasting, and driving all your scenarios. But we shouldn't forget that models quality and model calibration is a basic step before you start to use physical models.
And from a perspective, from a service provider perspective, it depends a lot on what the applications have in their reality. Sometimes they don't have too much data, even for start to develop an AI model using, I don't know, historical data or historical failure to compare, and also the applications don't doesn't allow you to implement a physical model, for example. So you want to establish a starting point using what you have in practice. So we have been doing some applications for for structural asset integrity, for corrosion monitoring, and at the very beginning you don't have too much to start, so you need to develop some basic physical models and start generating those data. Even though those data is not real time, for example, you can even rely on inspection, on using mobile in the field, or images or scanning and so on. But you need to establish a starting point and test those models and improve those models as long as you make it run. So this for some applications.
If I might add here as well, one of the uses of physical models as well with machine learning has been using the physics model to limit or constrain your machine learning outcomes. A lot of times your machine learning, or if you're using data just to predict data, you might get, of course, wrong results. Using physics models will help you constrain that and get more accurate machine learning results. So I've seen that as well being used, in addition to using the combination of physical model with a machine learning model.
Very good point, Ashraf. So constraining it with the physics model. So, perfect.
Exactly.
So let's
you still use
talk.
the machine learning as your main. Sorry.
Yeah.
I was saying you still use the machine learning as your main model, but you constrain it with your physics.
Perfect. That's a very good example. Yeah. Amit,
Noorddin,
you want to
if I
say
may
something?
add, like
Yeah.
Ashraf brought me something back to my mind. So, so even when we are talking of physics-based model, right, we have the steady-state models and we have the transient models. Again, you don't have to have a transient model every time because transient models takes a lot of effort to build and manage and maintain. So, based on what you're trying to do, a steady-state model might do the job. Again, it depends on what decision that you want to make, what questions you want to get answered. And second point about the hybrid approach, I've seen this, and there are some instances out there in the industry where you, because you want to make decisions, have predictions fast enough, sometimes the simulation models are not able to run in that time period. So in that case, there are situations where you would run the physics-based model and feed it into an analytical model and then analytical model and then use that to sort of do the real-time predictions. So there are combinations, but again the point is the same, that you start with physics as long as the physics models can help you use that to drive your models. And if physics-based models are not able to do what you need, then only then look at the pure data models.
Yeah.
So good. Thanks, Amit. So let's talk a little bit on the ESG perspective. So can we discuss or provide, if you can provide your view on cloud compute and data analytics, how in your experience that has helped the carbon footprint or reduce the emissions, or provide sustainability environment. So can we talk about that? Do you want to provide your view? Anyone else?
It cut out when you,
looks like
just as you said the name.
Yeah.
I didn't hear the name. Sorry.
Yeah, I didn't hear the name.
Okay, go ahead. Ashraf, you want to make a comment?
Yeah, I didn't hear the name. Sorry, the name cut, so we couldn't hear who you say.
Otavio. I was addressing to Otavio.
Oh, sorry.
Can you hear me now? Okay, sorry.
I didn't hear the name too, so sorry for that.
Oh, okay, sorry about that. Yeah.
I don't know. We are using cloud computing to perform and and in test environment and also in production environment to perform in a easier way some kind of models and some kind of prediction. So I believe it could be, I don't know, cheaper, faster, and of course it can be related to ESG environment. So but if I may, I don't know. Maybe in industrial environment, I don't know how much. I maybe I could transform it into a question for those that have more experience on that. I don't know. I would like to hear from bigger companies' perspective how they are using cloud computing environment and how it can be accessed, or how can be a collaborative way for smaller service providers or software technology providers to be more effective using the same environment to provide some solutions. So maybe Miriam can help me on the Schlumberger's perspective on that.
Miriam would like to jump in. Hi, Miriam. Do you want to?
Thanks. So we have got quite an interesting case study here. So as I mentioned earlier, our digital twins tend to be full end-to-end models of the oil and gas processes or the carbon capture and storage processes. So going all the way from the subsurface to the surface, or in the case of carbon capture and storage, surface down to subsurface. And those models tend to be very complex, which is then why we tend to use them in the design phase rather than in the operations phase. And cover the uncertainty space, as I mentioned earlier. However, the step change that big data and cloud computing has brought to us is the ability to run these models in a matter of days currently, rather than a matter of months as it was previously. And we're cutting that matter of days even shorter and shorter. And that decrease in time to run the whole end-to-end simulation is then enabling us to use those digital twins in the operational space rather than just in the design space. Because as I mentioned earlier, the definition of a digital twin being one where a live digital coupling of the physical asset to a functional output, that decrease in time that has come about from the cloud computing and from the big data now enables that to be a live digital twin in the real-time space that's required in the operational space. And then that step change of moving from design to operations then enables greater efficiencies to be made, both in the oil and gas production space, which then decreases the energy required and therefore lowers the carbon intensity of the oil and gas. But it also works the same way in reverse for the carbon capture and storage process. Increasing the efficiency then lowers the carbon intensity required for that carbon capture process.
Thanks, Miriam. Anyone else?
When we talk about digital twin, I think you mentioned it at the beginning, Noorddin. It's a digital twin of the world if we want to tackle the environmental problems, right? So to me, it's about breaking down some of the barriers when it comes to data across all the oil and gas energy companies by sharing the data in an anonymous way. So you can build digital twin and machine learning and algorithms that leverages data from all the operators to be more accurate and to be more of a replica of the whole environment. So when we talk about storage and capture and emissions, there's a huge value in collecting data from all these operators and countries and companies to build a comprehensive model. If you think about how the companies, for example, Maps, Google Maps or whatever Maps technology you're looking at, it leverages data from all over the place and put it together in an anonymous way. And that's really where I think the cloud and that kind of collaboration can help.
Yeah, correct. And the accessibility of this environment is it's a challenge nowadays when you are dealing with big companies' data and how you're going to treat it, how you're going to preserve those data. So, from our perspective, it's a big challenge, in fact.
Yeah.
And if I may add, basically, there's a quote from our Barbara Berger. She just retired. She was the president of CDV, and she said that innovation is a team sport. And in this space, what is happening is we are using different tools and different solutions to collect data and do analysis. But in the end, we need for all of them to work together. So there's a need for, again, in the previous presentation, Brian mentioned that all the vendors have to work together, all the partners have to work together to build an ecosystem where data can be exchanged and brought together seamlessly. It shouldn't take a lot of efforts and a lot of pain to bring all the data together. And once we bring all the data together, we have seen that democratization of the data to all the stakeholders has been very beneficial in the sense it has led to more efficient decision making. It has led to a lot of innovations and new ideas in how do we operate. So overall, if all the players who are working in this space can sort of, integrate and collaborate, I think that's when we can get a good value out of the solutions that we are building.
Exactly. Thanks, Amit. Yeah, data is an asset, and more data definitely is going to help make your operation run efficiently. Anyone else? If I have another question. So we talked about ESG. So let's talk about emissions. How do you think, and just give me an example, how digital twin supports emission reduction in capturing. We will talk more on the carbon capture, but from overall emissions, how digital twin can be deployed to support that sustainability goal while reducing overall emissions. Do you
I
have
think it's
any example in your company?
yeah. I would
Yeah,
like
go
to
ahead,
share.
Alberto.
I would like to share several examples, but first I think it's good to break the discussion into two pieces. No, the use of digital twin during the design phase and the use of digital twin during the operational phase. So I see that during the design phase of an asset, we are talking about process optimization. We are selecting the schema, the process schema. We are trying to achieve sustainable design, and a lot of the decisions that we are taking during the first stages of a project, no, visualization, conceptualization, even during basic engineering design, we are taking decisions that are going to impact the sustainability of our asset and the energy efficiency along the life of the asset. So we're going to live with the design for many years. So the digital twin can bring a lot of simulation capabilities and a lot of integration capabilities for the different discipline areas in order to get better, more sustainable designs. Then during the operational phase, I think the real use of a digital twin in regards to sustainability is that first it helps to bring a baseline for current emission levels, so you know what is your start point. Then as you draw your baseline, you can identify opportunities, so you can rank opportunities and you allocate your resources and your efforts to achieve the highest potential gains in terms of emission reduction. As well, you will be able to run forecasts. And some examples in regards to energy efficiency, for example, heat recovery from flue gas streams. So you want to maximize that. You want to maximize as well heat exchanger train integration. So, and this is a discussion that is applicable to upstream, downstream chemicals whatsoever. In regards to GHG reduction, I would say it's very good to, very important to track the different emission sources. No, if you're talking about venting, flaring, fugitives, leaks, or combustion or incomplete combustion from the different equipment. So you need to know which emissions you are having as a baseline, and then you need to start to allocate your efforts to decrease and achieve your net zero goals. And don't forget, I was thinking about chemicals and catalyst usage. Like, for example, you can use your digital twin to try to maximize your cycle runs for your catalyst and adsorbents, or for example, you could use your digital twin to try to optimize your dosing rates for a chemical that you may be using, for example, to inhibit corrosion or for flow assurance purposes. So there are many use cases. I think the digital twin, I mean, of course, is going to help achieve the net zero ambitions for the companies and help the industry to be more sustainable.
Thanks, Alberto.
Only for the flaring example Alberto gave us, 70% of the flaring emissions are coming from intermittent flaring operation that are due to poor reliability. So increasing reliability of the flare system, this is only just one example of the whole operation of an upstream installation can have a very huge impact in the emissions and also carbon footprints and energy efficiency. So just to give you some numbers here.
So, Otavio, as you mentioned, right? So one of the main thing is like how do we improve the reliability of our assets? Because if we run them reliable and stable, then we minimize any flaring incidents. That's one. Other low-hanging fruit that I always see is fuel gas consumption. So if we can optimize our operations to minimize fuel gas consumption, basically optimize our spreading philosophy. Those are things that the digital twin can help us achieve. Uh, so overall, yes, there's a lot of optimization and sort of uh, flaring and fuel gas consumption. I think are very low hanging fruits where if we can improve our reliability of our assets, leveraging digital twin, then that will have a huge impact.
It's good. Ashraf, you have a comment?
No, I agree with what you said. Yeah. Thank you.
Okay, so now let's talk about energy management system. I think digital twin has a great role to play in energy management system by optimizing the consumption of energy. Anyone wants to talk a little bit more about it? If you have an example of digital twin helping energy management.
I mean, I can refer to something we've done, which is optimizing our energy consumption of for generating energy in the field. Using natural gas and by using real-time optimization of your equipment and looking at your energy sources by building that digital twin of the energy system, we were able to reduce energy consumption by a small amount, but that small amount was significant enough to one, reduce our cost, but also reduce our emissions in the field. So yeah, this is a real example where we were able to simulate the whole process and using real-time optimization from real-time data to putting IoT and edge compute to allow us to do that. We were able to achieve those results. So definitely, it's a huge value.
Good. The simulation plays a big role there. Amit, do you have any comment, any experience in this area?
Yes, simulation has been leveraged, and in fact we are leveraging it very frequently. Optimize our energy consumption overall through our assets. So it has been a great tool to get to understand our energy usage and where the opportunities where we can make with a small change or with in the process we can reduce our energy consumption.
Yes, great. And I think, the point that we discussed before about removing the silos, if you have an end-to-end visibility of your energy consumption, and if your assets which are really not operational, but there is an energy usage there, you can optimize it if you have an end-to-end visibility. And digital twin plays a big role there. And also, about predicting your future energy requirement based on how the future looks like will also help you optimize the energy usage. Anything else? Anyone else?
Noorddin, to your point, right? So if you want to improve anything, you have to first measure it. So
yes,
the
exactly.
Twin with all the information, it at least gives you a measure of what your energy consumption is, and that's your sort of that's your baseline, and then you know
baseline,
what,
correct.
And from there you can figure out where you can improve. So that's the philosophy we go with. Like you got to first measure, and when you measure, then you can do something.
Yeah, and then going back to Ashraf's point about IoT, and I know that IoT, we have a lot of data being collected through PLC, the machines and stuff, and there are areas where you can deploy IoT sensors to collect more data. So just going back to your point, Amit, if you know what the environment looks like, where your energy is being used, what assets are being used or not used, uptime and downtime, using these sensors and the PLCs and all those things definitely is going to allow you to give a holistic view of how things are working in your operations. So taking this conversation forward, let's talk about, so a lot of oil and gas companies or energy companies now are transforming, as well as at the same time they are performing, performing and transforming. So there are assets currently being used which needs to be operational, as well as we are transforming. So can you give me an example, anyone, give me an example in the heavy industrial settings, how digital twin in any area can help you manage your existing operations effectively or efficiently, so that you can focus your attention to transforming to the sustainable energy side. Anyone?
Can I? May I? We have a few
Sure,
examples
sure.
here. And we have a pretty good results, like reducing shutdown in days for a few applications, in when related to maintenance of some structures in offshore environment, which means a lot because offshore operation is always complex. You need and every time you say that your offshore installation is down, it's a problem. So one example is exactly manage all the painted and coated system structures, piping, metal structures, static equipment, only creating a digital twin to manage corrosion and which are the critical parts you need to maintain to make an exact or precise plan or maintenance plan. So this is only one example in the operation and maintenance phase, and of course this have a lot of impact in ESG or in environment, in emissions, because downtime significant means losses in energy. ESG has a social impact, so every time you have more people exposed to the field or the environment, the risky environment of this kind of operation, it means again impact in ESG also. So I believe in looking to the operation perspective. I believe digital twin can impact a lot in the in the ESG data, so in the just the ES, sorry, ESG outcomes. So
Yeah, thanks, Otavio. Ashraf, you have a comment about the infrastructure side?
No, yeah, I mean, at the end of the day, again, reduction in emissions and how we can achieve that is not just something that we need to do because we can reduce money and we need to spend money. You need to spend on it. So being able to optimize and reduce your cost is key to that, and it is a social the right thing to do, and it's a social responsibility. So to me, using digital twin and optimization to reduce your cost is really key. And to do that, you need to start building those digital twins. Without it, it's going to be very hard.
Agree. Thanks, Ashraf. And Miriam, do you have a comment?
Yeah, it's an interesting perspective that that I'd not thought of previously in terms of how a digital twin can help in the ESG side. But listening to what the other panelists have been saying, it's clear that the advances in digital twins that have taken place over the last 10, 15 years, and particularly over the last 5 years or so with big data and cloud compute as well, the digital twins have progressed so far in their capabilities that now there's a lot less manual processing required, because the digital twin is taking care of it for you, and there's a lot less detailed expertise needed to actually run the digital twin. And then that frees up the people who were doing those kind of tasks. It frees them up then to work on other activities that could then further ESG activities. So those people could be accelerating the energy transition because they're no longer needed to be there manually hand-holding their digital twin, as it were.
That's great. Thanks, Miriam. So I think we have 10 more minutes, and I want to ask one more question, and then I'll go back to all the panelists to provide their one important things that they think our audience should take home from this panel discussion. So we touch a little bit on CCUS, carbon capture, utilization, and storage. Anyone has an example or has worked, deploying digital twin to reduce carbon emission using the CCUS?
So
I don't. Go ahead. Sorry.
no, go on, you go.
Directly,
I
indirectly,
was going to
that's fine.
say,
Yeah.
yeah, I would say that we don't have it operational right now, but we were building several carbon capture facilities and also building direct air capture, and we're in the process of looking at that as well, right? How can we use digital twin to optimize and reduce our cost? And it starts all the way from your engineering and design and construction to operation. One of the key takeaways I would say for our audience today is that you need to start your digital twin if you're building something from scratch. Start with the engineering data and use your digital twin to help you do quality control on your data. Use it during construction, use it, and then transition that into operation. I envision that in the future, the digital twin will start from the beginning. It's a replication of your physical world, and we generate a lot of that data during engineering. And we need to continue that cycle of managing data from the beginning all the way to operations, and then continuously updated during in operations. So I would say that yes, digital twin is helping us look at how we can reduce cost, but also it needs to start during engineering and design.
Thanks, Ashraf. So when we talked about data, we have data from different sources. In harmonizing those data so that you can make sense out of it. The data, especially when we talk about IoT sensors, we have different protocols for each sensors, and we need to consolidate or convert all those protocols into a single protocol so that we can make sense out of data. OPC MQTT, those are the key protocol that a lot of digital platforms using today. Any of you have experience or want to share, how do you address this issue of having data coming from different sites, different platforms, and different sensors in a different format? How do you harmonize it so that you can make some sense out of the data? Anyone has experience in this area?
Yes, I have. Oh, sorry, Amit, go on, please.
The question that you're asking is not an easy one. Basically, in the end,
Not at all.
there are different folks have approached it in a different way, but in the end, you need to define that framework, that ontology on which you're going to stick all your data. So, and what I would call is like the other way for saying that is like you need to normalize your data and have a framework on which you connect all the information coming in. Because only if you do that would you be able to then leverage that to sort of improve your decisions. In terms of like how we do it, there are multiple ways, but there is no easy way. A lot of challenges in achieving it.
Exactly. Yeah. That's why I pose. That's a big challenge. I know we need more data, especially to fuel your digital twin to operate effectively. You need data, and the data coming from different sources and different format is a big challenge. It needs to be addressed. Otavio, you wanted to say something?
Yeah, I would say the same thing as Amit just said. in my perspective, we need to check the application and then the framework and how we're going to contextualize this data into this application, into this digital twin application, and then establish the connectors and use. In fact, in a practical way, you're going to need to use what you have in that operation. So you're going to need to adapt. And once you have a framework and a robust tool that are able to contextualize and to treat this data and to scale this workflow of this data workflow into the operation, I believe this is the main point.
Okay, thanks, Otavio. We have 5 more minutes. Any other comment before we start to wrap up?
Yeah, I would like to add something. I think, and it's a discussion that we get almost every week now when we talk about digital twins, the importance of having clear asset hierarchies, naming and numbering, tagging procedures, the importance of having a clear asset registry, failure codes standardization. So when you are trying to perform root cause failure analysis, you're having failure code standardization for the events that have happened in the past. And also in order to ensure the standardization and interoperability of the digital twin, and the importance of life cycle management, and you need to be taking care of about all these discussions, and there are relevant standards that talk about this life cycle management, like for example ISO 15926, that I think brings a lot of clarity on this regard.
Thanks, Alberto. Anyone else? Okay, so we have about 4 minutes left. So I'm just gonna spend 1 minute each panelist and just give our audience your view of how digital twin helps ESG and a big challenge that we need to address. Just same question for everyone. So who wants to start first? Then we can go around the table.
So if I can jump in first.
Sure.
I think that in order to reduce emissions is exactly what we were saying earlier, right? You need to be able to measure in order to create that baseline, and then by measuring, you can then take action on where the key emissions or key reductions can be made. And having a digital twin makes that measurement and optimization process, orders of magnitude easier than just if you were to try to make those measurements and make those optimizations without a digital twin. So absolutely, in order to make the net zero targets for 2050, we cannot do it without a digital twin.
Thanks, Miriam. Good point. Amit?
So I'll build upon that. So basically, digital twins are going to be one of the enablers in our low carbon journey. And one of the key sort of sharing that I have is basically, traditionally we have had partners who have built like specific applications, and they work in their own bucket. But going forward, basically we need to work, and our partners have to work in a way that all the solutions can talk to each other. And as I mentioned, that this digital innovation will be a team sport. So basically, we all have to work together and to change that mindset of just focusing on our silo, but no, in terms of how does the application or the solution that we have works with the overall ecosystem, and basically
Thanks,
and
Amit.
sort of attach to that framework.
Thanks, Amit. So we have 2 more minutes. Just continue, Otavio. Short comment.
Yeah, I totally agree with both Amit and Miriam, and I believe digital twin and in fact digital tools and the flow established between data, digital twin and engineering application will have significant impact in ESG. Not only emissions or energy efficiency, but also reducing downtime, reducing impact in people, in the environment itself. So I just but you need to establish on uh, 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 thinking on how digital twin will work in overall system, but maybe start by smaller applications where we can start gains and we can start generate results and those, and then scale up those applications for even better scenarios. So that's my thought.
Thanks, Otavio. Alberto?
I would like to add something. I think a digital twin is really is really powerful in the sense that you can run as many scenarios as you want in a risk-free environment. I mean, and this is in regards to optimization of your current asset, but also in regards to unlocking new capex opportunities. So the fact that you're having a replica of your real asset where you can interact, you can run different simulations, and you can take decisions, I think is going to be really helpful in regards to energy efficiency and in regards to in helping the companies achieving their sustainability goals. Yeah.
Thanks, Alberto. Ashraf?
To reach our targets for emissions and carbon reductions, we have to do everything we possible. It's not one thing. It's not optimizing energy only. It's not only improving uptime. It's not reducing emissions. We have to do all of that. And data and measuring and understanding emissions and understanding volumes of storage, it needs to all come together for us to achieve those targets. So yeah, digital twin is going to be core to us achieving because it's based on data. So I think contextualizing the data and connecting it together to create that ecosystem is going to be critical for achieving those results that we want to achieve.
Thanks, Ashraf. And I don't see any questions from audience. I think we are at the end of our panel session. I just want to thank everybody, all the participants and audience for joining this session, and I hope this was valuable insights that you got out of this session. And I also wanted to thank our panelists for their expert opinion and advice to our audience on digital twin. And I'm sure deploying digital twin will help meet our ESG goal and carbon emission goal.